So parallel lines. You guys know what parallel is. Basically, they're lines that are coplanar. Okay? It means they're in the same plane and they don't intersect. So before, in Algebra 1, when you learned about parallel lines, there it is, they just said they're two lines that never intersect. Now, in geometry, now that we know, wow, awesome. Now that we know about planes, we can say, oh, they're in the same plane, and they never intersect. So, fairly straightforward. Now, skew lines are lines that are not in the same plane and do not intersect. We're going to look at some examples. And then parallel planes are just planes that do not intersect. So, parallel lines would be like this, okay? They're in the same plane, yeah.
I have one question. I think this was on a test, but can a line be non-coplanar?
Can a single line?
Yeah, single line.
No, a line always lies in a plane.
Okay.
And it actually was, single line lies in many planes, infinite planes. Two lines can be non-coplanar. These don't share a plane, right?
Yeah.
And this is what skew lines are. They're not coplanar and they do not intersect. So something like that. So over here it might be the line that goes through A and D and the line that goes through H and G. They never intersect and they're not in the same plane. Whereas the lines that go through A and D and E and H are parallel. So they're in the same plane even though they don't intersect. Okay? And then planes, if you picture two pieces of paper that go on forever and never intersect, those would be parallel planes. So the planes represented by the bottom and the top, or the two sides of the box, or the front and the back. So, let me get the whiteboard here. So an exercise would be to look at this figure and name a line that appears to be parallel to the line AB. So in this figure, which line appears to be parallel to AB and contains the point D?
DC.
DC, I agree. And now when we say DC, we have to put the line over it, when we write it, I mean, because otherwise it's just the length of the segment. Okay. Name one line that appears to be perpendicular to AB that contains D.
HD.
HD. Now, does that appear to be perpendicular to AB? Or can you see another line that
AD.
appears? Yeah, AD. I agree. Okay. And then we're going to name a line that appears to be skew. Now remember, skew lines are not coplanar and do not intersect. Appears to be skewed to AB and contains D. HD. I agree. Okay. And now a plane that contains D and appears to be parallel to the plane that has A, B, and E. So this plane here.
HDC.
HDC. I agree. And if you say HDCG, that's fine too. But three non-collinear points determine a plane, so HDC is plenty. All right. Good. Now, the first two here illustrate a couple of theorems. Through a point outside a line, so we had the line AB and a point outside that line, which is D, there is exactly one line parallel to the given line. So not only did line DC meet these criteria, it was parallel and there was parallel, but it's the only parallel line that goes through D. The only line that's parallel to AB and goes through D. And same thing with this one, we said AD, the line through AD is perpendicular to AB and goes through D. And in fact, there's only one line, and that's it, that meets those criteria. Okay? And then we have this theorem 3.1. If two parallel planes are cut by a third plane, the lines of intersection are parallel. Okay, well let's look. This would be an example. these two planes appear to be parallel, right? And this plane, DCG, cuts through them, doesn't it? So that would make HG and DC parallel, because those are the lines of intersection with this vertical plane and these parallel planes. Does that make sense? You follow that? Okay. So, let me scroll up. So what we're going to do, this is a lot of definitions we're throwing at you and a lot of new theorems, but we're going to be using these, and that'll help. Once you start using them, it helps you remember. More definitions now. Okay, so a transversal is a line that intersects two or more coplanar lines. Well, these two lines are coplanar. They're both on the whiteboard. You know, that's the plane they're on, the plane represented by the whiteboard. Okay? This line intersects both of them, so we call it a transversal, and we're going to call it T. Okay? Now, here are 3 definitions, well, 4 including transversal, that you need to get really comfortable with, because we're going to learn these definitions, we're going to learn some theorems associated with them, and then we're going to learn the converses of those theorems. There are going to be 5 different facts or theorems that you can use to help you prove that lines are parallel. And that's where we're going with all of this, is being able to prove that 2 lines are parallel. So we're going to start with just general facts. Alternate interior angles. Okay. If you have 2 lines and you have a transversal, the interior angles are the ones that are on the inside, in between those 2 lines. So 3, 4, 5, and 6 are called interior angles. 1, 2, 7, and 8 are called exterior angles. Alternate interior angles are ones that are on opposite sides of the transversal. Same with this, 4 and 5 are on opposite sides of the transversal, so they're called alternate interior. They're on alternate sides of the transversal, and they're on the interior. So, our alternate interior pairs are 3 and 6, angle 3 and angle 6, and angles 4 and 5. Those are our alternate interior pairs. Now, we have same side interior angles also. Same side interior angles, they're still interior, so we're talking about these 4, but they're on the same side of the transversal. Okay, so 4 and 6 are same side interior, and 3 and 5. Okay, so alternate interior, same side interior. And then we have what we call corresponding angles. And those are angles that occupy corresponding positions. So 1 and 5. These are both above the line and to the left of the transversal. 3 and 7, both below their lines and to the left of the transversal. 4 and 8, and 2 and 6. Those are what we call corresponding pairs. Okay, so we've got 4 pairs of corresponding angles. 1 and angle 5. Those are your pairs of corresponding. So it's a lot of vocabulary to get used to. Alternate interior, same side interior, and corresponding. Now, for corresponding, you could put corresponding core angles. Okay? Your book actually puts the little S in here. Okay? For same side interior, you could say SS int angles. So you don't have to write that all out. And for alternate interior, you could put alt int angles.